This is problem 433. I recommend looking in the book because I'm not sure how great my drawing is. But basically you have this pipe assembly that's subjected to a force at F. And we have some stuff about the dimensions here. So then from B to right here. That one is 0.4 meters, and then it goes down. .3 meters, and then it goes over to point C to 0.3 meters. Obviously not to scale. But they want us to find the moment of the force about point B. So if you remember, the moment about point B due to that force is going to be that position vector from B to C crossed with that force vector. So the force vector was given to us, so we have the force vector. So we need that position vector also from B to C. So I would recommend looking in the book again. But so for this one, it'll go, so we start at B, and then we need to go to C. So from B to C, we go, it looks like 0 in the I direction. So 0, I. And then in the Y direction, we go 0.4 meters, so we go to there, and then we go again 0.3 meters. So it's a little tricky the way it steps down. So plus 0.4 plus 0.3 meters in the J. And then in the K, we go minus 0.3 meters in the K. So R from B to C equals 0I plus 0.7 J minus 0.3 K, and that's meters. So for this, I'm going to use the determinant method. So M about B equals that RBC cross F. So remember to set up the determinant, we do I, J, K, and then the position vector for RBC is 0, 0.7, negative 0.3, and then and it's R cross F, so the force vector is 600 plus I plus 800 J minus 500 K. And so now we'll just do our determinant method, so we get I times, and then we do that 0.7 times negative 500 minus, and then it's negative 0.3 times 800. So that's the I. And then we'll do the J. So minus J times, and then we cross out that center one, 0 times negative 500, so that's just 0, minus, and then it's negative 0.3 times 600, plus K times, and then that's 0 times 800, so that would just be 0, minus 0.7 times 600. And so we can multiply that out. We get MB equals, on my calculator, so it's 0.7 times 500 times negative 500, and then the two negatives would cross out, so that'd be plus 0.3 times 800. That'll give us negative 110 I, and then negative J times, and then negative, or minus negative, so that'd be positive 0.3, enter 600 times, so that'd be minus 180 J, and then for the K we have 0 minus 0.7 times 600, so that'd be minus 420 K. And that whole thing, so the units are going to be, the force was in newtons and the distance was in meters, so it's Newton times meters. So that's our answer. So make sure you understand how to do that determinant method. That'll make your life a little bit easier.